Well, good morning, boys and girls. It's morning for me. It's early on Saturday morning. I'm trying to get this done for you guys. And we're doing 1-6. We're doing diagrams. See that? Diagrams. And this is an example out of the book. I think it's problem number 4. And we're just going to represent this network with these vertices, they're called, and the edges. That's mathematical lingo for the lines. And we're going to represent it with a matrix. So I'll do a couple of these examples kind of quick like, and you get out your pencil and paper and you can finish up this one. You can see I've got a matrix here, and we just want to represent A's connection to B and to I. Well, we can do A's connection to B like this with a little 1, and B's connection to A with a little 1 right there. I filled in the diagonal row of zeros there to show that there's no loops going back to connect A to A. So they'll all be zeros. It kind of helps keep us oriented. Then C connects to B, so I put a 1 right there. C does not connect to A, so that's a 0. Okay. D right here does not connect to A, so that's a 0. Only other thing that connects to A is the I. So way over here, I'll put a 1, and everything else will be zeros then. Okay. So then the B connects to C, connects to A, connects to E and H, but there's no other connection, so the rest of those are zeros as well. Okay? So it's pretty straightforward. You can just go through. There's the answer for you. Okay, now I'm going to do number 7 on page 41. It's doing the opposite. It's taking a matrix and putting it into a network diagram. It's pretty straightforward. Sometimes you'll need to do a rough draft and then a final copy, but I'm just going to put 5 dots in a circular order to start with, and this is going to be J, K, L, M, and N. And then I simply read across and I look, and J is connected to M and N. So J connects to M and N. Pretty straightforward. K connects to L, M, N. K connects to L, M, and N. And so on. L connects to K and M. Already connected to K, but L connects to M. And then M connects to J, K, L. M connects to J, K, L. Already done that. And N, that's that one right there. And N, you'll see, connects to 3 others, and they're already there. So this is my rough draft if you want. If I were to redraw it, I think that I'll leave that up to you though. But you can see the ideal is to not have anything cross, because that creates the impression that there might be a vertex right here, but there isn't. So if I take J and put J right here, then I can very easily draw this without those. Okay, and you can see that's a more accurate representation of that network. Okay. Okay, now this is problem number 19 on page 43, one in which you are supposed to schedule final exams with no conflicts between courses. And you can see the courses I've abbreviated: chemistry and English and French and history and so on. And a line represents, or an edge, as they call it, represents a conflict where you've got 2 or more students that have French and English, so you cannot schedule the exam at the same time. So the rules are pretty simple. You just start anywhere you want, like with an E, and you color that in, red in this case, and then you shade any other courses in that have no conflict, no lines connecting. So there's no line connecting E to L, so I can shade that in red. There's no line connecting E to D, but there is a line connecting L or E to S, but there is a line connecting these two, so I cannot shade those in. There are no other courses that I can shade in that are not connected to either one of these two. So I change my colors, and I'm going to go to green, and then I can start with this one. There's green. Now this does not connect at all to H, so I can do history down here. I cannot shade this in because these are connected. I cannot shade these in because these are connected. I cannot shade those in, so I'm done with green. Now I go on to black, and I shade this one in black. And this one is connected to this one, but it's not connected to science over there, so I'm shading that one in. and I cannot shade this one in. But there's only one left, and so I'll leave it. So I've now got my 4 possible time slots. My first one I could schedule English and literature, and you'd think there might be a conflict there, but there apparently isn't. And then I could do chemistry and history at the same time. I could do science and French at the same time, and little old mathematics has to go at the end or the beginning all by itself. Okay, here is the goal scored in the second period of the hockey game, and it's diagrammed in matrix form. It's pretty straightforward, just like you've done. The question in the book, though, asks, what does the row and column mean? Well, these are the rows going this way, and these are the columns going this way. And I think what they're getting at is that these represent the to passes, and these are the froms, right? So you can follow and see that Anders here passed to player B, Blair, and he passed to Rawson. And passes were received in the from column. B received a pass from A, and Terry received a pass from Davis. But by going down the goal column, you see the goal was scored from Davis, and then you can trace it back and follow the flow of the play. It's up to you to decide whether you like this type of representation of that goal, or if you like the names with the arrows. Okay, so you can do part C, comparing the 3 periods and answering that question. All right.